to HydraBlend Technology video podcast. I'm the developer of HydraBlend Technologies. I started this project not only to showcase my skills and talent in software development, but I would also like to develop a useful service to share to the cybersecurity network. Technology enthusiasts, software developers who are interested in getting involved in the progression of this project. I try to incorporate the best practices for a freelance small business from my own personal knowledge and experience in cybersecurity and software engineering. So HydraBlend Technology is a web service that I allow my users to archive data that they collect from reconnaissance scans provided in cybersecurity tools, cybersecurity distributions such as Kali Linux, which allows users to collect external reconnaissance data from tools that are supported in the Kali Linux organization and operational system. So in here, HydraBlend Technology is a web service. This highlights the basic communication and workflow of HydraBlend and how the different service-oriented design communicates with each services contained in HydraBlend Technology. It's a private cloud service that I will eventually scale out to a cloud environment. It uses multiple self-contained services dedicated for its own personal job, and it integrates in total to a web project that allows users to interact with the web site and conduct data archiving jobs, and also run analytics, also design analytics, some sort of framework that they can use to create and manipulate data as they please. So in summary, HydraBlend Technology, it's the modules that are going to be provided by HydraBlend is going to allow users to collect vast amounts of data and conduct analytics and reconnaissance, all different types of jobs from many open source data that are available in today's market that are underutilized. And I believe that the services provided by these open source data can provide a lot of information that often go overlooked. Okay, so HydraBlend Technology, it provides users a web application which is designed in Angular. The client will request from the web server an Angular page design application, which integrates with a middleware Java API technology. Now the web server that I'm using currently is running on a self-container environment running on CentOS Linux stream server, hosted by a Tomcat instance. Okay, the middleware application, the middleware Java API application, will communicate with an Ubuntu server and also an Oracle Linux server, which contain these database services of MongoDB and Oracle SQL. So the job of the API container is to retrieve data from the databases and provide the data available to the user. The middleware application also has access to an FTPS server that will allow users to upload files in the form of zip format, and the zip file will now be archived into an FTPS server from reconnaissance scans, external reconnaissance scans, and those individual files contained in the zip will be processed by a worker service file processor. And the other container that I left from my personal server is a Kali Linux server running a Metasploit team server. And the internal service of Metasploit uses a PostgreSQL database. Okay, so the fundamental concept of cybersecurity, it's a basically the operations of a blue team and a red team, where red team hackers would try to exploit security flaws, and blue team hackers will try to are in a race to patch those flaws, etc. And as a service or a company grows, scales exponentially large, the infrastructure for blue team operation has to increase vastly. They have to fix every patch detail. They have to be very thorough, because the blue team security, the security infrastructure have to be very thorough in their configuration. The hacker only has to find one vulnerability in their design to be successful in a remote exploit or damage to a company's asset. Okay, so now this tool right here, HydraBlend technology, is really a tool for anyone to use. It's not just for red team. It's not for blue. It's also for blue team. Blue team and red team can take this data and integrate as they please. Blue team operations can archive their data to run their own penetration testing, and they can keep track of their assets. And as red team will try to mine as many data as they can. So HydraBlend technology also incorporates security to allow users to secure their data as they will, depending on their subscription level, etc. And the plan is to also allow this operation to be available to any user. So however the user wants to use their tools and archive their data is depending on the user and their desire and their goals and objectives personally. So I would take no responsibility in where the data was collected from. All my service is doing is archiving the data and allowing tools to integrate analytics. So this is a data analytics platform for large data, open API source data, user collected data, etc. Okay. So this is the design of HydraBlend. Now I was very thorough in my design. I decided to use open source where possible to relieve myself from having to manage license and third-party complexities with their compliance and license. And in some cases, I also integrated a design which works very well for its own service. As you can see, like an FTPS server worker service, I decided to go with the Windows Server 2019 solution. They have particular advantages for this style and design, and also the development I've done with the application layer also integrates well. For example, you will notice that a Java application is running on a Tomcat instance container. It's integrated with Oracle Linux and Oracle SQL, all Oracle technologies. An Ubuntu server containing a MongoDB, which integrates well to dynamically design the front-end application, dynamically built-in design templates that can be built directly off the database. So database-driven front-end design, dynamic design, front-end layer from database. Okay, and the worker service is a .NET application, which also integrates well with Windows DLL services, and also the IIS FTPS solution, which I believe is a secure solution, as opposed to me configuring an FTPS service on an open source platform, which I believe is more vulnerable for an FTPS solution. So that's the reason why I went about this approach in design. Okay, so that is basically the software service-oriented architecture design. A more thorough design can also incorporate like the network security, which is much more, considering that it's a home office, that I'm developing these services on a single server. I decided to develop it on a virtual network security platform that has a potential to integrate with the cloud. So there are multi-level firewalls, private DMZ zones configured, a virtual networking infrastructure, and virtualized container services. So this right here is the network security, the firewall uh, integration, network communication design. There we have a physical server right here, which I call nyvert00, which is like, considered with the naming convention of the services I'm running. I'm also designing the platform dependent on that. The ports that I allow access for my personal development environment, and also the ports allowed access from the web service, is they're just separate layers in communication. Um, and the entire goal is to scale the service to eventually cloud burst it into a cloud environment, which will allow a self-contained uh, single open HTTPS port to allow users access to a web application. And the internals of that connection will be internal communication with its own private network environment. So there are no leaks to access. Everything is accessed via HTTPS web application. To the user, no external vulnerable ports are available, and the internal communications are restricted via needs of the application and configured and secured through its own private security that I developed, and also the network security applied, and the system configuration, etc. Okay, so let's go about okay. Going through the rundown of opening HydraBlend technology, I'm running this service. The authentication layer here is done through Facebook single sign-on. If I were to if I were to open an incognito and I go through the process of single sign-on, I can go log into Facebook. I will click this link and it would direct me to a Facebook login page. So to prove the security of the authentication, I can go ahead and sign into my Facebook. And you'll see that the security for authentication is handled by Facebook, including single sign-on security. If you have dual factor authentication, etc., it'll be handled over here. And this is all done by Facebook. Oops. So Facebook is going to request me a two-factor authentication. And just so I'm not making this up, I get the request from my device. I'll go ahead and allow access. And there we go. You're going to see the redirect. maybe a little bit slower on network connection. Okay. Than normal, but okay. All right. So I believe Facebook is taking some time. Okay, considering maybe I have multiple running processes, I might be suffering from some sort of performance issue. Whatever, just continuing on. Once we have the login, you can see the application can handle persistence of the user being logged in. So if I open up new tab, run in, it will automatically log me in. Given that Facebook has permission to the application only retrieves the user email and the name of the user. And I decided to use Facebook as an authentication layer due to security reasons, and also not having to manage a large user database for authentication purposes. So I thought it would be a good solution. Also, Future allows me to integrate LinkedIn and other platforms like Google Authentication as well. Now, currently, just for demo purposes, I have deactivated the other HydraBlend modules because they're not completed yet. So I'm currently focusing on developing this one external reconnaissance module to a full completion, which is taking quite a bit of time because of the amount of work that is a part of this development. So HydraBlend technology also incorporates a social media aspect that's currently in development. So here I have myself. I can edit my social profile, and I can put up a list of information to have a social media feel and aspect to it, and even allow users to engage in posts. I may build a similar forums, a knowledge database, even a something like a Craigslist. I was thinking would be pretty good. And one of the advantages of HydraBlend and HydraBlend's social media aspect and development is that I'm not going to be taking your data and giving it to someone else. I'm not going to be allowing people to mine your data here. I'm not going to restrict your free speech freedom, and I'm not like some sort of I'm strictly developing the service for internet freedom, and that's one of the advantages that we can do as people, is develop our own services to combat these monolithic corporations that are taking over everything. So this would be a really great way to get people to engage and also encourage others to develop their own services with their own technical skills and knowledge. Okay, so just an idea. Just want to make sure that so if I edit the data, it will continue to save. Okay. So all right. Let's go into the introduction now. External reconnaissance. We have like an introduction page to describe the service, and also some links to the prerequisite tools used to engage in external reconnaissance. We have the CaluLinks tool here. And we have a GitHub here. Okay, it's taking some time. I believe some pages are taking more time than others. But anyway, this is a link to the GitHub repository for external reconnaissance. Um, so yeah, so this is the original tool that was developed in Kali Linux as a part of Black Hills Information Security, InfoSec of Black Hills. So they developed this tool. This guy right here, Landmaster53, his name is Tim Tones. He developed this tool with external reconnaissance, which has a lot of good potential for future updates, and it's a very useful tool in Kali Linux, and it has a very smooth, streamlined data collecting feature. But the tool is limited in its ability to manage data. Um, and it's hard for any user to manage their own data within a tool like this. Uh, and there's a lot of information that can potentially be used in mining, useful in mining, and so that's the reason why I started developing a cloud platform for some of these tools, because as a cybersecurity red team operations, you're in charge of managing your own tools, and it could be very time consuming if you cannot put it into process for automation. So that's one of the reasons why I'm developing this service. So as you can see, the introduction, I also give access to some videos to show users how they can use this tool effectively, and I've also handpicked these videos to really go into something that is useful. Okay, so one of the features of HydraBlend technology is that the UI is very dynamic. As you can see, there are various relations. All the features of the UI that is displayed. So inside external reconnaissance, I can dynamically generate the side panels in the UI. As you can see, introduction, analytics, tasks, data tables. All of these things in here that are built on the side panel are dynamically generated from MongoDB database. The design of that I chose, why I went with MongoDB, is because the ability for MongoDB to dynamically generate models and update its data, which is a very good feature for dynamically developing UI, because I can use reusable functionality, like redesigning the same templates over and over again for other modules, and maybe customize it to some degree. By developing like this, I can effectively design one module and dynamically develop other modules more rapidly, and which is an advantage for someone that's developing a very large service as a single developer, one developer on a team. So I went along with this approach, and you can see everything in everything in HydraBlend technology, the UI is dynamically generated from DB. Even every single page, every single aspect of every single every single page navigation, everything. So, for example, if I go to introduction, see all this data, and go into MongoDB, we go to introduction, and you see this object that creates the title. We have the title here. We have the weaponized information for attack. We have the paragraph, quotes, quotes by, a list of objects, which are the links displayed in here. So all this information is dynamically generated. And also the carousel object for YouTube videos are driven by the Mongo database that creates all the links for all the videos embedded and etc. So if I would like to develop another tool with an introduction, I can also modify this modify the tool's own object by its module ID, and dynamically generates its own videos and headers and etc. So going into analytics, for example, this page, although the data is not designed particularly for this tool, it just displays like the UI feature. So the charts, for example, I have an array of charts. The element of the chart, which would describe if it's a big data or not, or whatever the title of the chart is. You see total shipments. You see total shipments, the style of the chart, completed task, daily sales, total shipments. So all these things are developed or dynamically generated by data. So as you can see, all this stuff right here. So even accounts, purchases, sessions, so those are the selection for these values here. So we have a big chart data, we have a chart red line, subfill graph of total shipments right here, 76325, 2125. So we see all these values right here displayed in the charts, including the data. So as you can see, everything here is dynamically generated. Okay, so if I were to modify the data, let's say I'll take the 70, make it 120, refresh. As you can see, something has changed here, 120 right here. So just like that, the data can actively and live be updated live. So there's a lot of potential for the structure of this design. So that's one of the reasons why I went with these design, because I can always, so you see we modify data, etc. So this design is very flexible, unique, and it can update live. So that's one of the reasons why I went with this flexibility, and it's very nice to have a platform that, as you're running on a screen, instead of like clicking refresh, you have a set timer that's going to update frequently, and you can see live data update. So one of the so you get the idea. Every single side panel, everything in here is dynamically generated in HydraBlend technology. And let me actually go back and introduce some of the other modules. So going back into modules, I've actually inactivated a lot of the modules here. And the reason I inactivated them is because they're not fully developed, so still going to take some work. But the idea is that we get the idea of how much capacity this service can potentially have. Okay, so if I were to go ahead and refresh this page now, you see all the modules of HydraBlend technology and the potential for it in the future. So we have a finance market analytics platform, we have a census data analytics platform, the external reconnaissance platform, wireless scan dumps, internal vulnerability assessment, digital forensics analysis, exploit tracking database, and exploit development project module, social media miner, AI data analytics, reverse engineering, penetration test reporting, risk management directory. So this is going by, I think there was one that was still inactive, which actually also have a botnet development projects. So as you can see, there's many potential for this service to expand. So let's go into the external reconnaissance. Let's walk through it from the beginning of how external recon worked. Okay. So here I'm actually remoting into my personal laptop, where I have a Kali Linux distro and an external reconnaissance project and which I can work with. And I'll go into discussing the complexities of why collecting data just from a laptop environment is very difficult to be an effective penetration tester or cybersecurity analyst, enthusiast, technology, whatever you are. As you can see, I'm going to go ahead and I'm going to start up a reconnaissance external recon module. And first, before I do that, I'm actually going to shut down my services just so I have some extra bandwidth in my CPU usage. So a whole bunch of things loading up. Let's shut this down. Okay. Let me just take a look into some of my TeamViewer stuff. I don't understand why we have this large network bandwidth issue. Okay, so go ahead and I'm going to go ahead and start up reconnaissance. Seems to be some heavy delays here. Okay. Okay, so starting up Recon engine. Alright, so as you see, this is the project that was developed by Tim Tomes. And I'm having some really bad lag here. Okay, so this tool is a tool written in Python, and it allows users to basically go ahead and collect a whole bunch of information that is contained in open API source, open Google source, anything that is out there in the internet. There's a whole bunch of modules that developed modules that allow users to collect data from these open API services. So the basic development skill here to get engaged in developing on top of our Recon engine is, using basic Python programming, and also being able to fetch data contained in URI, HTTP requests, and parsing data into format. Okay, that is bad. So, excuse me while I reestablish connection. Maybe are you on like heavy video chat or something getting a lot of network lag.
You want me to turn off my Wi-Fi?
No, baby, it's good. Jeez. Let's see. Okay, so we're back. Hopefully this connection is better. Is looking a lot better. Okay, so the first thing so you can navigate into the available command list in Recon engine by typing in help. That would really help you view all your options. The other thing you can do is you can use reconnaissance in many external Recon engine in various ways, and you can even access it as a developer to make changes to the project. So I've actually committed a change. Well, I've actually supported the tool for Kali Linux upgrade between Python version 3.8 to Python version 3.9, which broke in some of the modules that is used by external reconnaissance. Okay. So yeah, so basically every time the operational system upgrades, or every time it upgrades a Python version, some of the previous dependencies could be broken. So therefore, you can support the tool. I want to show how people can access the tool more as a developer to debug the tool and make changes. So the first thing you can do here is go to I put out a command here, so let's see if it shows on this page. So my team viewer is very slow for some reason. I think there's a lot of things running. So okay, so you can type in the command options list from default. Let me go ahead and start closing down some browsers. Hopefully free up some bandwidth or space. Give me a quick minute while I check my router. Okay, so maybe I will not be able to demo a Recon portion of this video, unfortunately. Okay, let's move on. Let's just go past Recon, and maybe I can do a demo on another video or something. So let's assume that we know Recon, and you have the ability to collect information from Recon engine. So what to do next? Basically, Recon will save your data in a local database project, DB file, which is accessible through, I believe, Microsoft Access, and also you can also load it into SQLite within Kali Linux. So now, although you can view the data and you can run queries on a small SQLite environment, which is the way I've been accessing it, notice that the way you manage your own data in Kali Linux is it's very limited in its potential to maybe, let's say you extract the data you collect and you want to build something on top of it. Like, for example, if you want to create some sort of analytics platform for AI, for instance, your ability to utilize the data is very limited because the data that you collect is very small. But if you have a platform where you can store a large amount of data, then your analytics and data mining skill can be very powerful. It creates another layer of what you can do with large data. So going ahead and run this tool, and let's just assume that we have collected our data from external reconnaissance. Unfortunately, I cannot show how to collect the data from external reconnaissance. Do this. I don't know if it's TeamViewer. I don't know if it's a network connection. I don't know if my process is quite a bit of. I'm using quite a bit of process because I'm running all these projects at once on my local computer. So I'm gonna go ahead and take it one step at a time. And neither do I want to bother trying to figure out what's wrong right at the current moment. I'd rather just make a streamlined demo of my tool instead of trying to fix the issue right now. Okay. So although the okay. So I have that connection here. Okay. So that's good. All right. Let's go back to demoing. All right. So once we collect our reconnaissance scans, we're going to have a list of CSV files that we can extract from these scans. The way that I do it in Kali Linux is I will load the data of the data.db file from the external reconnaissance. I'll take it and I'll load it up into SQLite database built into Kali Linux. So once I've have the data in SQLite, I can take all my data columns and I can choose to extract those files or export those files in a CSV format. And you would like to extract the files with the header columns present. That's the only prerequisite, and maybe in another video I can show how that is done. So the scans that you collect in the CSV, you can also open it in Excel. It will format into a table for you in Excel. But you'll get the gist of the kind of information you can collect. So in my demo, I decided to collect a external reconnaissance of Bank of America for demo purposes. And these are some of the examples of the data that you can collect. So you plug in Bank of America and you run a whole bunch of modules and tools in external reconnaissance, and your external recon engine will go ahead and mine data in the public internet to find information about Bank of America, including past employees, employee emails, their region and location, the country that they're located in. If your API keys are strong enough, if you have the ability to gain very quality keys, you can run modules to also collect their credentials. Like if their credentials were ever leaked, you can map contacts, previous contact employees, their emails and password. So that's what the credentials are. Dashboard is a overall summary of your reconnaissance report, what modules you ran and how many times they have successfully run to create your data. So you can gather all this information in a CSV format. Okay. Once you have extracted these CSV files from your reconnaissance, just giving an example, the modules that you've used in reconnaissance and the number of times they ran. Okay. So just giving an example. And once you have your CSV files, what you want to do is you want to select all, and you want to zip it up into an archive. Okay. So you zip it up into an archive. You can call it document. We'll call it a zip file. I only work with zip files in here for this project so far. So you can go ahead and zip it up into a file, rename it, use the format .zip, and you'll have your BOA_test zip file. Like it could be whatever company you're working with, but Bank of America, I decided to go with called it BOA_test.zip. If you did it for any other company, you call it whatever you want. To give that zip file some meaning. Maybe you want to add a date, like 05/06/2021, to your scan, and you would want to organize your zip files in your own compressed way, whatever it is. So the contents of the zip file will contain no folders inside or nesting of folders. Just simply have all your CSV files inside a zip. Okay. So once you have that, you can go ahead and go into HydraBlend. So I'm going to go into tasks, and I'm going to decide to upload a new task. Inside my upload, I'm going to just give an example. I gave a small description of how to input some of these parameters. Like for example, the company, find the company full stock market name on Google search. So go ahead and label as an example, Bank of America Corp. The market, find the company's associated market on Google search. The market Bank of America Corporation runs on is NYSE, New York Stock Exchange. Find the company's stock code on Google search. So his company stock code is BOC. Today's date, you can just go ahead, hit enter, or you can go ahead and just click today. Nice flexibility. Recon engine zip file. So you'll take your zip you collected, you'll go ahead and upload that zip and add a detail, summary detail, Recon scan done. BOA employees. Go ahead and put this in. Okay. I'm going to go ahead and I'll upload that file. Give it about 10-15 seconds and you'll see your file uploaded into your workflow task. All should be running. Not, I fear. Oh, right there, we got it. Okay, so basically, there may be some time that the connection to the FTPS server and the size of the file will take. Okay, but we have our scan uploaded. Okay, so and also we will have the workflow request created on this MongoDB that will display the data that's connected in this workflow task. So you have all your field responses saved. You have the status of the job as queued, and the status is active, and the progression and the timestamp of the file. Okay, so that's how it's currently stored in MongoDB to show in the UI interface. Okay. So once you have this, pending workflow task, I kind of rearranged the UI. So I'm going to allow the users to click into detail. It's going to show a pop-up form to see the details of the scan. And if any errors are collected or anything like that, you're going to see the details. You're going to see the final status as the scan progresses. And while the scan progresses, you're going to see the progression of how the data is uploaded and how the UI integrates all your data and stores it and archives it the data. Okay. So once you have the workflow job, what happened in the back end? Let's talk about what happened in the back end. So basically, the service, the API service, created a workflow request, and it saves all your field response data, etc. And what happened to the zip file? Let's talk about what happened to the zip file. I'm going to go into FileZilla. And I'm going to create a connection to my FTPS service. Just give me 1 minute. Okay. Alright. There's probably a problem with this computer's connection. Okay, alright, so I just repaired the connection, I don't know why. Okay, so I'm gonna go ahead and FTPS into my server. So, as you can see, I'm gonna drill down to my FTPS service, and you're gonna see a list of folders that have been created. Okay. Alright. So as you can see, the FTPS service with the API, it created a conventional folder structure and hierarchy to organize the data that has been archived into HydraBlend. So the files have now been transported to an FTPS service with some sort of relation between the work service. So the relation here is the user account ID. So this user account ID is created for the user after login. So these are the values that I have extracted from Facebook, which is my email, my name, the photo, and also my let's take a look. And basically it generated a client ID. This is basically my user ID. So this user ID is equivalent the same as this user ID right here. So basically the FTPS account created a folder for the user. It created a folder for the module that you're using. So the workflow request has been created under a module. So this module ID is reflecting the external reconnaissance module. This is the external reconnaissance module. So for every user, user has a list of modules. So the module ID is created as a folder, and inside the module you have a list of scans or work requests that you've submitted. So the idea here is that the workflow request submitted has been created its own separate folder where your zip files have been extracted and stored into the FTPS service. Okay, I don't need this one anymore. That's an old workflow service. Okay. Okay, alright, so now I have one. Alright, so now you have all these files that have been uploaded, and you can also see the file size that was also uploaded for each file. Okay, now that your file is currently stored in the stored inside the FTPS service, what's going to happen here is there's going to be a worker service that's going to run and is going to collect those files and process them into an Oracle database. Okay, so all of this development I've done, very lengthy, very a lot of work has been put into this. So it's a very monolithic service as it is. So even the API layer has a lot of work behind it. That's just one project. It's contained in many different projects. It's many different projects that integrates together to create the API service. And finally, basically, we have the database. So we have the MongoDB instance, and now we have the Oracle SQL service. So these are the three main scripts that create the Oracle DB. That creates all of this databases contained in HydraBlend. Okay. So I've also done some work to create some security on the data itself. So security user group relation contained and can be created by modified by the user. Security group settings allow access to the data as you see fit. And dynamic queries to retrieve the data. allows various filters, ability to sort, functionality, etc. Um, for the data. So all these tables, type objects, procedures, functions have been created, and also some of the database procedures created to modify the data. Okay, so these are still working in progress, but just enough to demo the changes. So this is currently what I'm working on. Alright, so basically when I run this process job, it's going to process each file and is going to dump it into the Oracle SQL database, and it's going to also create some properties of the user, etc. And this worker service typically takes about 5 to 10 minutes to process the Bank of America file. And as you can see, while this worker service is running, I'm going to go ahead the diagnostics. You can see the CPU utilization, the processing memory. It's going to take some time to run the service. And as the process is running, you're going to see the status change. And all of this stuff is going to happen in the backend. It's going to happen in the backend, and it's going to go ahead and take some time to process the data. And while these services are doing its job in the back end, the user would be able to see the overall progress take over step by step. And this process will take usually about 6 minutes. And depending on the size of each file, we're going to see some time variations and differences. So the default processor is default. I've set it to about running every 15 minutes, collect all the data and process it asynchronously. So that's the job of the processor. It's going to process large amounts of archive data, etc., and is going to basically process it and create security, data security, and also dump the data into a large database, Oracle SQL. Okay. So it's going to run its job and it's going to update the progress, and this process will take usually about 6 to 10 minutes. And as it's progressing, you'll see the overall status once it finishes. But once it's while it's progressing, you can also see that the data, some of the data may be available while it's processing. Maybe I'm going a little bit too fast. So let's go to companies. Let's go to contacts. Okay, so as you can see, some of the data is available as it's being dumped into the database. So, okay, so if you go back to your task and you can see the overall workflow progress. And once it completely finished, we'll see a status update. We should see a status update. Oh. Okay. There's a unique constraint that was violated. Okay, so unfortunately, the progress failed with a warning, and maybe a small bug in the processor that I have to fix. But basically, the error also shows that the files failed due to a unique constraint that was violated in the process. But does not mean that our whole service failed. It just executed with a warning. We can also see the data. Some of the data has been uploaded into our database, which we had seen previously. Excuse me, I believe the network is pretty slow in here. Okay. Alright. Alright, so there was a warning that has been issued because of a key violation in the backend. So I'll go ahead and fix that error when I get a chance. But just going through the functionality, as you can see, how can you use your data? We can edit data. Now there are lists of data that you can edit. If you find out from your external reconnaissance, you're able to add more data from your own personal research or something else in the company, or some sort of methodology you use that is outside of the tool that you used for external reconnaissance. You can go ahead and decide to also add your own data and modify your own data inputs. Yeah. You can modify your own data inputs and create your own values. You can also edit any data that you feel like you have more information. Something, I don't know. And you can also do everything you need to do. And we also have, like, you know, if whatever edit that you do, I also allow you to undo the functionality, and when you're fully committed to the changes, you can also save the data. You can go ahead, delete the data, etc., and finally you will save the changes. So the UI is very flexible in its ability to work with data and modify the job as effectively as you require. So that's the whole idea of this tool. And even with that, that process error, I'll have to take a look into it. But it's quite a bit of work. It's very it's pretty exhausting. But not that I'm working on it very frequently, but something that I am working on the side. The potential for some of these panels moving forward is this locations, which is going to generate a Google Map data. For the data that is collected, you can extract locations and insert push pins, and the push pins will be related with the data that was collected in that area. There's a location data that you can utilize here for that. And so for this portion, I think I'm going to change the side panel to a security and allow users to create security per workflow, allow security group access, allow individual user access and the level of access they can grant to users, etc. So stuff like that. Potential for analytics would incorporate some of the data that is collected from reconnaissance, including if you look at dashboard, the effectiveness of each module used in reconnaissance. I think it would be good to run analytics, and also the data that is collected in the table as well. Let's take a look at information workflow security. So some of the data, I believe, not that good. Okay. But yeah, so you can see the modules that were used in reconnaissance and the number of runs per module, which could be useful. But also, I'm going to go ahead and end this video soon. Just to go over just a small demo in progress. So some of the data that I'm navigating between relation is also the market value and the stock code of each company, which can be used to collect the number of reconnaissance conducted for that particular company in the stock code, and also filter companies by stock code, and generates analytics of the number of reconnaissance, and maybe even collection in relation to cybersecurity attacks, and also the affected, like, stock values, etc. So that there's some sort of relation that can be created for, like, companies and its cyber attacks, and maybe its effect on its assets, for example. So various ideas come into mind, but definitely a development in progress. But thank you for tuning in. This has been the updates of my current progress with this technology, and all right, have a good day.